pieces. Next. Okay. Kita. Sunod ha. Wow. Oh my God. Oh my God. This is it. Let's open one piece. This is the 8-channel relay. 1, 2, 3, 4, 5, 6, 7, 8. 8 digital IOs here. Input. 10 amps, 250 volts AC. Then control is 5 volts. 5 volts. 8 relay module. Okay. So this is the other one, the Lolin Node MCU V3. It has a Wi-Fi and then a microcontroller unit with around 8 digital IOs and a few analog IOs. USB. What's this? This is the entire package.
So this is part 2 of the video. So here I'm setting up a simple circuit. So this circuit simply connects the board with several other components. Here in the source code we have the password and the SSID for the Wi-Fi. So the power on the board is actually just taking in 5 volts, and you can just power it using your regular cell phone charger or power bank. And here is the port 80 server for the device, some of the analog input and digital output pins. I've also set the initial LED state to 0 here, and then we have in the setup some code to initialize the pin mode. So we set that to output for the LED, and then we write the initial output, which is 0, so to the LED, so that would be turned off, and then we initialize the serial comms and then also the Wi-Fi using the SSID and password. And then we also set a few of the check the Wi-Fi status if it's connected, delay a little bit, and if it still doesn't connect, do this until it really connects. So this is just an infinite loop until it finally connects. So if you have a wrong username and password, SSID and password, this will be a huge trouble to debug. But anyway, we also have here the print for the IP address, so that initially we can check what is the IP address of the unit, because it's stored in code by then. Then we have this server.on, which handles the root. We have this set for the DNS name for the device, so it's called ESP8266 in this case. And then we also have the root route, this on the API, so we pass that to the handle route, and we have an inline example here. So we have a response. This works as well in plain text, so that would be a response 200 or OK. So it's also defined here in the handle root function. So essentially what we have here is a variable for the string output for the plain text, and then we anytime we receive a request to the root route, then we change the LED state from on to off or off to on, and then we also read the analog pin, which is analog 0, and then make up the sensor value. So essentially sensor value is fed from the analog sensor pin, and then once we have that, we send the response to the client. That would be a plain text and response 200. We also set the LED state on the serial for debugging, and then finally we write the LED state to the LED itself using digital write API call. So this is a very simple handle not found implementation, so like a 404, response 404. This is the infinite loop where we do the handling of the client. So that part there actually takes the bulk of the process. So now let's move on to the browser. So this is example of the actual IP address of the device that we have right now. So the device is now connecting to the Wi-Fi using that IP address, DHCP IP address. We test the inline, and then we receive the this works as well response that we have in our source code. So here it is, this works as well, so we have a good response. Let me change the zoom actually. Okay, so this is a better zoom. Going back to the code, so going back to the root link that is handled by the handle root function highlighted here. So once we press enter, if you observe the light emitting diode there, it turns off, but there's a red light on the other module in that blue block sort of module. That's actually the 8-channel relay, which turns on if there is no signal. So it's I think normally off relay. So this relay, what it actually does is controls AC units such as alternating current units in 220 volts. It's capable of handling up to 250 volts AC, 10 amps. So we have 8 channels for this, and I think we have channel 5 right now that is working. So if you, depending on how you wire your AC unit, such as for example TV, air conditioning units, lights, AC lights, fluorescent lamps, any sort of appliance in the home, depending on how you wire that in this module, that will either turn off or turn on, normally closed or normally open, because this I think is a 3 node relay. So it all falls on how you wire stuff in these terminal block. So you can just put this entire project aside. It has an antenna in the main IC itself, and then you can just power it with a power bank, and it will still work if the code is already there and it's isolated. So if I press the F5 button, you can see the lights turn on and off, and yeah, it is roughly equivalent to turning your AC device alternating current, the one you plug into your wall socket, that you wanna turn that on or off by simply browsing this API. So a good way to do this is designing a better call, such as the one I'm writing here, for example, API slash analog out. So what happens for this is perhaps read what value is in the sensor, and then we have DO1, so that would perhaps write a high state to the digital output, and then on the digital 0, and if you only put in D0 without a /1, that would probably be equivalent to reading what's actually in the what the current state of that pin, whether it's a high or a low. And then if I change the sensor by rotating the potentiometer here, the sensor value changes if I refresh the page. So you can see what I'm doing here as I'm rotating is that I'm actually changing the analog input for the analog 0 pin of this device. So the sensor value is simply taken from the analog read of the sensor pin, and the sensor pin is the analog input 0. So I think this device only has one analog input, so I think that's it for this device and the analog input. So this is just a very simple example. I'll put the source code in the links below, and then of course you can improve it. Thanks for watching.